సార్ సిగ్నల్ ప్రాబ్లం ఉంది.
అవును సార్.
ప్రసాద్ సార్ సిగ్నల్ ప్రాబ్లం ఉంది. Let us wait a while.
Online classes, so that is statistics for both media in 10th class in our DCB Sudapeta online classes, and already completed Telugu medium also, real numbers in Telugu medium also. He working as a mathematics school assistant and participated in so many orientation programs. We are very pleasure to have such a great teachers teaching to our real numbers. So please, Ashok sir, please go through the concept.
Thank you, sir. Good morning, all of you. So this is my second class in English medium. So already the sir said I taught statistics. Now today we are going to start the first chapter in our textbook, that is real numbers. Okay, today we are going to discuss the first chapter in our textbook, real numbers. So, and as well as it is the last chapter in our online classes. With this class we conclude our syllabus. So once again, very good morning to teachers and students. So today we are going to discuss about real numbers. So from the beginning of our study, from first class to now till 10th class, in every class we are discussing or we are dealing with numbers. So there are different number systems we have discussed so far. So once we recap what are the number systems we have studied, and we will move to the new topics whatever we have in our 10th class syllabus. Okay, all of you know very well about the number systems. The first one is natural numbers. Okay, these number system is called as counting numbers. So in this number system, the numbers begin from 1 2 3 4 dash dash. So whenever we ask to count anything or some any items, we will start with 1 2 3 4 and so on. So counting numbers or countable numbers, these are called as natural numbers. The first letter is n. So this number system is indicated with the letter n. Dear children, listen carefully, and whenever you require, please note all the points. I will go slowly. Okay. The second one is whole numbers. So what are the digits in this number system? Along with natural numbers, the only one digit extra, that is 0. So if you place 0 in natural numbers, so that is whole numbers. Means whole number system contains the numbers from 0, 1, 2, 3, 4 and so on. In natural numbers, the smallest number digit is 1. In whole numbers, the smallest one is 0. So already we have discussed sets. So regarding the sets concepts, natural numbers is a subset of whole numbers. Means every natural number is again a whole number. Why? All the numbers in natural numbers are again in whole numbers. Okay. Next one is integers. So in this, along with 0 and positive numbers, we have negative numbers. -3, -2, -1, 0, 1, 2, 3 and so on. In this number system, we can't say the smallest one or the greatest one. So in the number system whole numbers 0, 1, 2, 3, 4 and so on. If you place negative numbers, so that is called as integers. This number system is indicated with the letter I or Z. Means this number system contains both positive numbers and negative numbers and again 0. Okay, comes to next one. Quotient numbers are simply, we know very well, rational numbers. Okay, this number system is indicated with the letter Q. So we have discussed about rational numbers in 9th class. So what is rational number? What are rational numbers? So these numbers in the form of P by Q, where P and Q are integers and Q is not equals to 0. Okay, so is every natural number is again a rational number? Come on, tell me. Means in rational number, each and every number which is in the form of a fraction or P by Q. So every number in natural number, 1 or 2 or 3, we may write this, we may represent this as in the form of P by Q. In 9th class, we did so many sums. So express 3 in the form of P by Q means we write 3 as 3 by 1. If you multiply both numerator and denominator with the same number, for example with 2. So 3 by 1 means if you multiply with the 2 both numerator and denominator, that is equal to 6 by 2. 6 by 2 is nothing but 3 only. So every number can be written can be represented in the form of P by Q. That's why every natural number is a whole number and every whole number is are integers and all integers are rational numbers. So n is subset of W, W is subset of I and I is subset of Q. Okay, all these three number systems means all the numbers whatever there in these three number systems, those are all will be in this number system. So out of all these four number systems, this rational numbers is the biggest one. Okay. So till now we have discussed all these topics in 6th and 7th, 9th classes. Now we are going to discuss one more chapter, one more number system. That is, come on, tell me what is that? Irrational numbers. So rational numbers indicated with Q, irrational numbers indicated with the letter Q dash. So what is an irrational number? Simply the numbers which are not rational is called as irrational. So the numbers which are not rational, that is called as irrational. So we know very well about rational numbers. So we may express every rational number in the form of P by Q. So this irrational number, these numbers which we do not express in the form of P by Q are called as irrational numbers. If we express in the form of P by Q, that is rational number. If you didn't express in the form of P by Q, that is called as irrational numbers. Okay. Now comes to our topics, our chapter name, real numbers. What is real numbers? Simply, it consists of both rational numbers and irrational numbers. Real numbers means it consists of both rational numbers and irrational numbers. So among all these 6 number systems, which one is bigger? Yes, clearly real number system is the biggest one of all the number systems. So in this 10th class, we will discuss different properties or different applications regarding this number system. Okay, if you express with the help of Venn diagram, so Q is rational numbers, Q dash is irrational numbers. Okay. So real numbers consist of both rational and irrational. So we may express this in the form of Venn diagram like this. Okay. Now we will discuss a few properties regarding this number system. So first of all, I am introducing a topic. So look at this table. Number of fruits are 8. Number of persons to share, there are 2. So we are dividing 8 fruits among 2 students or 2 children. So come and tell me, each one get 4 fruits. So anything remaining? No, that is 0. So after doing division in lower classes, just we have verified whether it is right or wrong with the help of division fact. Okay, 8 is equals 2 into 4 plus remainder. Is there anything remained? So no remaining means so here we put 0. 8 equals to 2 into 4 plus 0. Means we are sharing 8 fruits to 2 persons. So each one get 4 and no balance, that is 0. Look at this one. Now number of fruits are 9. So 2 persons are sharing this one. Means we are dividing 9 fruits to 2 children. Here, after getting each 4, one fruit is balanced. Simply we call this as remainder. Okay. So 9 is equals to 2 into 4 and plus 1 balance, that is plus 1. Generally, while dividing 9 with 2, what we call 9? Yes, dividend. What is 2? Divisor. This 4 is quotient and this 1 is remainder. Okay. So in that way, we will check whether the division is right or wrong with the help of division fact. Now comes to one more example. Now we are sharing 8 fruits to 3 persons equally. So here each one get 2 fruits and 2 are balanced. Now same as write like this, 8 is equals, we have divided 8 with 3. So 3 into, here what is 2? It is called a quotient. 3 into 2 plus 2. Okay, look at here, 3 into 2, 6 plus 2, 8. So our division is right. Next here, 9 is equals 2 into 4 plus 1. So 2 into 4, 8 plus 1, 9. So we tally with the help of division fact whether our division, whatever we do, whether it is right or wrong, we will check. Now, one more example. So we are sharing 9 fruits to 3 persons. So clearly each one get 3 fruits and no fruit will be left. So that is equals to 9 is equals to 3 into 3 plus 0. So finally, number of fruits are 10. So number of persons to share, they are 4. So each one get 2 fruits and 2 fruits will be left. So 10 is equals to 4 into 2 plus 2. Look at here, 4 into 2, 8 plus 2, 10. So our division is correct. So in generalization, let us assume number of fruits are A. So number of persons to share, they are, just assume B. Okay. So we don't know how much will each one get. So assume it is as Q. Suppose remaining fruits are, assume it is as R. So basing on the examples, write this one. Yes, A is equals B into Q plus R. B into Q plus R. So we are using this one from lower classes. So it is, look at here, in general, in A is equals to B into Q plus R. Here R value always should be greater than or equal to 0 and less than this B. What is B? B is divisor. So remainder always should be less than divisor, and it may be equal to 0 or greater than 0. So we know very well here A is called as dividend, B is called as divisor, Q is called as quotient, R is called as remainder. So these are all basics. So whenever you require, just copy the slides whatever I am telling, and after completion of this session or this class, so practice the example sums and exercise sums whatever you have in textbook, and ask your teachers if you have any doubt. So if you follow in this way, then only you can understand the topics whatever I tell here. Okay, in A is equals to B into Q plus R, the remainder R value always should be less than this divisor and greater than or equal to 0. So here A is called as dividend, B is called as divisor, Q is called as quotient, R is called as remainder. Okay, look at next slide. So this is called as division algorithm. Whatever I have discussed till now, A is equals to B into Q plus R, that is called as division algorithm. So look at the statement once. Given positive integers A and B, given positive integers A and B, there exist unique pair of integers. There exist unique pair of integers Q and R. Q and R satisfying A is equals B into Q plus R. A is equals B into Q plus R. Here R value is 0 less than or equal to R and less than B. This condition is most important. So R value lies between 0 or greater than 0 and less than B. This is called as division algorithm. So look at once again. Given positive integers A and B, there exist unique pair of integers Q and R. So those Q and R satisfying A is equals B into Q plus R. Here R value, that is 0 less than or equal to R less than B. This is called as division algorithm. Okay, whenever you are dividing A with B or one number with another number, so there should be possibility of existing of a remainder and a quotient. So those two in such a way that they will satisfy this condition. A is equals to B into Q plus R, and R value always like 0 less than or equal to R and less than B. This is called as division algorithm. So Euclid's algorithm is based on this division algorithm. Euclid's algorithm is based on this division algorithm. So we'll look into the topic. So here, this Euclid's algorithm is a technique to compute HCF. What is HCF? Highest common factor of two numbers. So in lower classes, we find HCF of given two numbers with the help of a division. So the same thing we will find here by using division, Euclid's algorithm. Okay, so I will explain with the help of an example. So look at the question once. Find the HCF of 60, 100 using Euclid's algorithm. Okay, so you have to find the HCF of these two numbers by using Euclid's algorithm. Before that, simply observe here in 6th or maybe 16th or 7th classes, we find the HCF using this division. So what we did there? So we divide the bigger number with the smaller number. 61 ja 60. Okay. So 40 is the remainder. Again, with this remainder, we divide the divisor. So again, divide 60 with 40. 41 ja 40. So again, if you subtract, the remainder is 20. Again, with this 20, again divide the divisor 40. Continue this process till you get the remainder is 0. You have to continue the same process up to the remainder 0. So look at here, 22 ja 40, the remainder is 0. Whenever we get the remainder 0, the divisor, here divisor is 20. This 20 is called the HCF of given two numbers. HCF of given two numbers. Okay. So we apply the same thing in 10th class in Euclid's algorithm while finding HCF. Okay. Now just see how to find HCF using Euclid's algorithm. Okay. So what is Euclid's algorithm? A is equals B into Q plus R and 0 less than or equal to R less than B. Okay. Here he has given two numbers 60 and 100. Take 100 as A value and 60 as B value. So always the dividend should be greater. That's why the 100 I have taken as A value and 60 as B value. Okay. Now look at this one. Means you are dividing 100 with the 60. So 61 ja 60. What is the balance? 40 balance. So 100 is equals to 60 into 1 plus 40. Okay. Here we won't get the remainder 0. So continue the process. Now divide the 60 with the remainder. So 60 is equals to 40 into 1 plus 20. Okay. 41 ja 40 plus 20 is remainder. Write like this. So next here we didn't get remainder as 0. So continue this process. Now divide 40 with 20. So 40 is equals 20 into 2 plus remainder is 0. Okay. So whenever we get the remainder 0, so the divisor, whatever the divisor is there, that is the HCF of given two numbers. Look at here. We get remainder 0 here. So this 20 divisor is called as the HCF of given numbers 60 and 100. Look at here. When remainder is 0, then the divisor is HCF of given two numbers. So now finally HCF of 60 and 100 is 20. So in this way we will find the HCF of given two numbers. So this question may comes in the examination for 1 mark or 2 marks. So you have many sums in do this and in as well as in the exercise. I will explain one more sum. So this is a way to find the HCF using Euclid's algorithm. Okay, children. Move to next slide. So we have 4 sums in do this. So find the HCF of the following by using Euclid's algorithm. So 50 and 70, 96 and 72, 300 and 550, 1860 and 2015. Okay, I will explain one sum in this. So that is second one. Find the HCF of 96 and 72 using Euclid's algorithm. Okay, come on, tell me what is A value, what is B value? Yes, very good. You have to choose the bigger value as dividend, that is A equal to 96 and 72 as B value. Okay, always you have to keep in your mind this Euclid's algorithm. What is that? A is equals B into Q plus R. Always R value means 0 less than or equal to R and less than B. Come on. Now 96 is equals to 72 1 just 72. So what is the remainder? Come on, 24. Okay. So here we did get the remainder as 0. So continue the process until we get the remainder 0. Now divide 72 with 24. Means 72 is equals to 24 3 ja. Yes, 72. What is the remainder? 0. Okay. So we get the remainder 0. So here what is the divisor? Yes, this number 24 is the divisor. So HCF of 96 and 72 is 24. So why we have chosen 24 as HCF? So our condition is when the remainder is 0, then the divisor is HCF of given two numbers. So we got 0 as the remainder. So at last HCF of 96 and 72 is 24. Okay. In this way, you have to do the sums in do this and in the exercise number 1.1. So look at here. Now we'll discuss different applications of division algorithm related to finding different properties of numbers. Means based on this division algorithm, we will find different properties of numbers. So look at one example. Look at here. Show that every positive even integer. Show that every positive even integer. We know about integers. These integers consist of negative numbers and positive numbers. In that we have to take positive and again even numbers. We know numbers are even and odd. So show that every positive even number is of the form 2q and that every positive odd integer is of the form 2q plus 1. So where q is some integer. Means you have to show every positive even number, even integer is of the form 2q and every positive odd integer is of the form 2q plus 1. Okay, we will prove this one with the help of division algorithm. First of all, you have to understand the question. What he has given, what he is asking us to prove. First, you have to get clarity on the question. Okay, now by using division algorithm or Euclid's algorithm, so I am assuming A be a positive integer and b is equals to 2. I am taking b value as 2. Okay. What is given algorithm? Yes, a is equals to b into q plus r. Okay. B into q plus r. Here 0 less than or equal to r less than b. Here we have chosen b value as 2. Okay. Means a is equals 2 into q plus r. So this 2 is, we have chosen b value as 2. That's why we have placed 2 in place of b. A is equals to 2q plus r. And the remainder, this r value should be less than 2 and greater than or equal to 0. Means if you divide a number with 2, what are the possible remainders? 0 or 1. If you divide a number with 5, then what are the possible remainders? Means if you divide with 5, the possible remainders are 4, 3, 2, 1, 0. Means 1 less than the divisor. So here we are dividing with 2. So remainders are 0 or 1. So R values are 0 and 1. Okay. Now if R is equals 0, just now we have seen R values are 0 and 1. If R equals 0, then put here R value 0. So A is equals 2q plus 0. So now here we have assumed R value 0. So right here, so means A is equals 2q we are getting. Okay. So we know very well multiple of 2. Multiple of 2. These are all even numbers. We know very well. So A is equals 2q. So this A is in the form of an even integer. Okay. Why 2q is even? Means any multiple of 2 is even number. That's why this A is in the form of an even integer. Now, if R is equals to 1, then what will happen? A is equals 2q plus 1. Sorry, here I didn't write the form. Here A is equals 2q plus 1. Okay. So R equals to 1, then A is equals to 2q plus 1. So this 2q plus 1 is in the form of an odd integer. Why? Just now I proved 2q is an even number, even integer. So in our number system, even numbers and odd numbers will appear alternately. If we add 1 to the preceding number, so we'll get the next number. Means if 2q is even, if I'm adding 1, so if you add 1, the next number will be odd number. Okay, so A is in the form of odd integer. So finally we get what he asked. Every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1. Students, did you understand here why 2q plus 1 is odd integer? 2, 3, 4, 5. Look at the numbers. 2 is even number. If you add 1, 3 is odd number. Next one, add 1, 2, 3, you will get 4. 4 is even number. So alternately, even numbers and odd numbers will come. So 2q is even number. So if I add 1 to this one, 2q plus 1 is clearly that is an odd integer. So finally, we have proved every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1. So we have to prove like this. Okay. Now we'll move to one more sum. So look at example number 2. In your textbook, show that every positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Read the question once again. Show that every positive odd integer is of the form 4q plus 1 or 4q plus 3. So again you have to use division algorithm. So here 4q is there, 4q plus 3 is there. So you have to take b value as 4. So the number which is side of this q, whatever is there, that you have to choose as b value. In the previous example, I have taken b value as 2. Here I am taking b value as 4. Why? Here 4q is there. If 5q plus 1 is there, you have to choose b value as 5. So here you have to assume b value depending upon this value. Okay. Let a be a positive integer, and I am assuming b value as 4. So now by division algorithm, now tell me what is the statement? A is equals to b into q plus r, and 0 less than or equal to r less than b. In the examination, you have to write every time, each time for any problem, you have to write the formula. So there is a allotment of marks for formula while doing the sums. So for any problem in the examination, you have to write a suitable formula every time. Okay. Now a is equals to, sorry, here 4q plus r. This slide is 21. Okay. So I have taken b value as 4. Now a is equals to 4q plus r. Here 0 less than or equal to r less than 4. Means while dividing with 4, the possible remainders are 0, 1, 2, 3. Okay. Here b is equal to 4. So possible values of the remainder, r means remainder are 0, 1, 2, 3. Now if r is equal to 0, if remainder r equal to 0, then what happened? Put here a is equal to 4q plus r. Here put r value as 0. So a is equals 4q plus 0. So I am writing 4q as 2 into 2q. 2 into 2q. Why? 2 into 2, 4, again it will get 4q. So a is equals 2 into some integer 2q. Means this 4q is multiple of 2. And we know very well multiple of 2 is again an even integer, even number. So if r is equal to 0, then what we get? A is equal to 4q. This is in the form of even integer. Okay. What you have to prove? Odd integer. Odd integer is of the form 4q plus 1 or 4q plus 3. So these two are odd, means remaining are all even numbers. So now r is equal to 0. Then we get a is equal to 4q. This is the form of even number. Okay. So here keep an eye. I am writing 4q as 2 into 2q. If I assume 2q is equal to some p, 2p. 2p means multiple of 2. So multiple of 2 is always an even number. That's why a is equal to 4q is in the form of an even number. Now, come on, tell me, if r is equals to 1, then a is equals 4q plus 1. Clearly, it is odd number. What I'm saying, 4q plus 1 is an odd number. So my question is, why 4q plus 1 is odd number? Very simple. Just now we have proved 4q as even number. If you add 1 to 4q, the next number will be odd number. Why? In our number system, already I told you, even numbers, odd numbers will come frequently, one by one. 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even. Like, means if you add 1 to the even number, you will get odd number. If you add 1 to the odd number, you will get even number. So 4q is even number, 4q plus 1. Next number will be odd number. Okay, we have proved one part, 4q plus 1, odd integer. Okay, if r is equals to 1, then a is equal to 4q plus 1 is odd number. Now take r value as 2. Okay, if r is equals to 2, then a is equals 4q plus 2. So take 2 common here. Take 2 common here. 2 into some integer 2q plus 1. Again, if you assume this entire 2q plus 1 as some k, now a is equal to 2k. 2k means multiple of 2. Means that is even number. In this way, you may prove, or one more way is there. Just now we have proved 4q plus 1 is odd number. So this is one more than 4q plus 1. So in that way also you may prove this as even number. Okay. Now if r is equals to 3, then what happened? Look at here. A is equals 4q plus 3. It is odd number. Why? It is just one more than 4q plus 2. So clearly 4q plus 2 is even number. The next number, one more than this number, is clearly it is an odd number. So finally we have proved what we have proved. Every positive odd integer is of the form 4q plus 1 or 4q plus 3. Okay, so this is a way to prove. So you have to practice the sums, then only you can understand or you can do anytime. So look at few sums in exercise number 1.1. So in first bit, use Euclid's algorithm to find the HCF of, here he has given 3 sums. So just now I have tell how to do. So practice these 3 sums. Okay. So these all sums are same as example sums. Just I will tell this third sum. Look at here. Use division algorithm to show that the square of any positive integer, is of the form 3p or 3p plus 1. So this is the last sum for today's class. After this I will close. So look at this third sum. So you have to practice the remaining sums. Okay, children. Look at the third sum in the exercise 1.1. using division algorithm to show that the square of any positive integer is of the form 3q or 3q plus 1. So after reading this sum, come and tell me what is the value for b you have to assume. So you have to assume b value as 3. Why? Already I told you 3q plus 1 or 3q. Basing on this, you have to assume b value as 3. And a be a positive integer and assume b value as 3. Okay. Now, basing on division algorithm, what we write? A is equals to b into q plus r. Here r value is lies 0 and b, means 0 less than or equal to r less than b. So here we have taken b value as 3. Now a is equals to put b value 3, means 3q plus r value keep it as same. So 0 less than or equal to r less than 3. So here square of any positive number integer means you have to square both sides this one. Squaring on both the sides. That gives a square is equals to 3q plus r whole square. What he has asked? Square of any positive integer is of the form 3q or 3q plus 1. So you have to square this number. Okay. This is looks like a plus b whole square formula. In the place of a, you have 3q. In the place of b, you have r. I think all of you know the formula of a plus b whole square. A square plus 2ab plus b square. In the place of a, 3q is there, put a square, and 2ab. In place of a, 3q, in place of b, r. So a square is equals to, what we get? 9q square plus 6qr plus r square. So in the first two terms, take 3 common out. If you take 3 common out, 3 into 3q square plus 2qr plus r square. Suppose this 3q square plus 2qr is equals to some k. We assume this as k. Now it becomes a square is equals to 3k plus r square. A square is equal to 3k plus r square. So we have taken b value as 3. So possible r values are 0, 1, 2. Okay, now if r is equals to 0, then a square is equals to 3k. A square is equal to 3k. So if you assume k is equal to p, then a square is equal to, p. P. Okay, a square is equals to 3p. So we have proved one thing. Next, take, if r is equals to 1, then a square is equals 3k plus 1. Let's assume for k is equal to p, then we get a square is equals to 3p plus 1. A square is equal to 3p, and again a square is equal to 3p plus 1. Next, finally, if r is equals to 2, then a square is equals to 3k plus 1. 3k plus 2. 2 square means 4. Next slide. Okay.
Sir,
Sir.
టైం దగ్గర పడ్డది.
Just 2 minutes, sir. 1 minute.
ఓకే.
So a square is equals 3k plus 2 square. 2 square means 4. I am writing 4 as 3 plus 1. In these 3 terms, in the first 2 terms, take 3 common out. 3 into k plus 1 plus 1. Assume k plus 1 as p. So a square is equals to 3p plus 1. So therefore, by proved, square of any positive integer is of the form 3q or 3q plus 1. So do the remaining sums. So this ends today's class. So and finally, advance happy new year to all the students and teachers from both the districts. Thank you, sir. Thank you very much.
So thank you very much, Ashok sir. That is the end of the first day of our real numbers class. Sir, screen sharing.
Okay, sir. Okay, sir.
So thank you very much, Ashok sir. That is the end of the first day real numbers class. So wish you all a happy new year in advance. See you on 2nd, 9 o'clock, same time with Ashok sir and continuation of our real number. Thank you very much for the technical team who supported for the online program since last 6 months on.